Let me bring you up here, Shaked. Hey, Shaked, how are you?
Hi, Nick. It's so good to be here. Thank you for having me.
Oh, and thank you for being a tremendous supporter of APIsec University. You've contributed courses, your expertise. You've helped us make this event possible. I'm going to give you the stage because I don't want to take time away from you, but thank you for being here, and please take it away.
Okay. So hi, everyone, and thanks so much for joining me today for this session on API security in the automotive industry. I'm Shaked Edry, Data Analyst Team Lead at Upstream Security. I'll be sharing with you insights taken directly from our vehicle SOC and how we've seen API-based threats in our ongoing monitoring activities. I'll take this opportunity to thank Dan and the APIsec team for the opportunity to share this information with you and for putting together this con, where we can share from our experiences and hopefully ensure a more secure automotive and smart mobility ecosystem. In this session, we'll get to view things from the VSOC analyst perspective, understanding the anomalies in the data that may point to a threat, and wrap it all up with how to better secure automotive APIs. Okay, so let me introduce Upstream. Upstream offers a cloud-based XDR platform designed specifically for the automotive and smart mobility ecosystem. The Upstream platform helps customers unlock the value of vehicle data. It does this by transforming scattered vehicle data into centralized, organized, and contextualized data lake, enabling the creation of connected vehicle applications such as cybersecurity and API security, which leverage contextualized vehicle data for anomaly detection. With Auto Threat Intelligence, Upstream delivers the first cybersecurity threat intelligence solution for the automotive industry. This provides top-tier cyber threat protection and actionable insights seamlessly integrated into the customer's environments and Vehicle Security Operations Center, VSOC, which is at the core of today's session. Upstream operates worldwide with 2 Vehicle Security Operations Centers. As the industry has grown and expanded, the threats have evolved too, and there is a need for a dedicated team who monitors and acts to mitigate threats to connected vehicles and mobility IoT devices. We believe that API security for automotive, fleets, mobility applications, and transportation operations is a crucial part of the cybersecurity stack, because so much of the communication between those devices, consumer vehicles, commercial vehicles like trucks and agriculture equipment, to name a few, are connected and all use APIs to operate. The examples from our VSOC showcase why a dedicated vehicle-oriented SOC is crucial to maintain operational continuity. So let me explain how VSOC, or Vehicle Security Operations Center, works and why it's so crucial for the automotive industry. So first, let's imagine an IT security team. They continuously monitor and analyze an organization's security posture using systems, processes, and a team of professionals. Their goal is to detect and respond to cyber threats, protecting the organization's information systems from attacks and breaches. SOCs are commonly used to monitor IT systems, infrastructures, and assets at large organizations, including OEMs. But unlike IT infrastructure, which OEMs directly manage, vehicles are constantly in motion, and they're not directly under the control of OEMs and interact with external systems and applications thousands of times a minute. As the number of sophistication of cyber attacks targeting vehicles, mobility applications, OT and IoT mobility services increases, OEMs must develop integrated VSOCs, also known as mobility SOCs or automotive SOCs, to protect their vehicles, infrastructure, and customers during the post-production phase. An effective VSOC is essential for the security of connected vehicles and the smart mobility ecosystem. It allows OEMs to monitor their entire infrastructure and vehicles in real time and respond to detected threats quickly. However, with the constant expansion and digital transformation of the smart mobility ecosystem, more stakeholders are expected to require a VSOC. Mobility IoT vendors, fleet systems, and other smart mobility service providers will shift to monitoring and protecting their assets via VSOC. When properly implemented, the Vehicle Security Operations Center, or VSOC, has a clear plan and a strong strategy with a clear vision, mission, and goals. A VSOC, of course, should operate 24/7. It should collect and compare data from different automotive sources. It needs to find threats and problems quickly using special cybersecurity tools for vehicles. The VSOC should look into alerts and predict threats before they happen by using expertise and threat intelligence. It should actively search for threats and have clear rules, procedures, and processes. It should also create and follow detailed plans to handle and automate responses to issues. And lastly, the VSOC should connect with Siemens SOAR platforms to make sure there is visibility across the organization and efficient problem solving. By following these steps, a VSOC can protect vehicles, infrastructures, and users from new cyber threats. This is our Ann Arbor, Michigan office. Let's go to the VSOC and view threats from the analyst's eye. Now, I promise you, we don't usually point at threats like this, but let's check out some API-based threats that the team has shared with me. We'll understand what the platform API security solution detected and the implication these API threats have on product, the vehicle, or the fleet. Okay, so we'll start with credential stuffing. Credential stuffing is a cyber attack where attackers use stolen usernames and passwords from one breach to try and gain unauthorized access to other accounts. A threat actor will try to exploit the common bad habit of reusing same credentials across multiple sites and services. Our API security solution detected an uptick in the authentication requests reaching the authentication manager. And then the investigation started. Since a significant spike in the authentication requests hitting the authentication manager mechanism was detected, the traffic relating to this mechanism was first drilled down on. Digging deeper, the VSOC analyst found the tokens from the account management system was being used to extract vehicle data and send commands to the cloud server. This was promptly addressed with a relevant playbook, which is set in place to trigger systems which block the unsecured accounts and invalidated the compromised tokens. And just recently, there was another published incident where credential stuffing was used to expose customer PII and then utilize this information to redeem gift card points and essentially committing fraud. This was done by getting into the online billing and service platform and then redeeming reward points for the use at an OEM. The product impact here is quite clear. Data leaked, which potentially means compromising consumer PII, or as mentioned, accessing accounts, which can have financial impact beyond just privacy. In the original example, where vehicle data was being extracted, had this been left unaddressed, then the threat actors may have been able to send action invoking commands to vehicles. This could have resulted in a fleet-wide attack, of course, potentially impacting thousands or even millions of vehicles. To reduce the risk here, organizations should consider implementing multi-factor authentication, rate limiting based on IP and user CAPTCHA to mitigate the impact of attack attempts, WAF implementation that considers the device expected behavior and fingerprinting the device, API security solution with real-time monitoring to receive alerts on trigger automated playbooks when an anomaly is detected. And on a general note, as a consumer and a business, of course, you should always have strong passwords and rely on pre-recognized data so that if your password was in a leak, you could proactively replace it. Now, another possible way for a threat actor to gain access to a system is unauthenticated API calls. Here, a threat actor makes requests without proper authentication, usually because the API hasn't had sufficient security placed on it or due to oversight or the rapid development processes in place. The VSOC team discovered an internal API with several endpoints, which were all unauthenticated. These were internal APIs, which means they're not exposed to third parties or the public, which lowers the overall risk, but there is still the risk of sensitive data being exposed and leaked. There are also cases where an external facing API doesn't have sufficient authentication measures, and information such as EV charger usage or the location of the charging station maybe has been exposed. The example here is an API that exposed the details of dealership employees. It listed all employees on the site, complete with emails and even names. Basically, the threat actor could have extracted this information by just sending a read request and receiving the response with the full information. Now, to mitigate the issue, a token requirement was added, ensuring that only permitted people would have access to it. Here, the way to reduce the risk is fairly straightforward. Make sure that all APIs in use by the organization include an authentication mechanism. If an API must be left unauthenticated, then add rate limiting, reducing the risk and the possibility of misuse of the API to access data. This is where an API security solution with traffic monitoring capabilities and granular investigation capabilities can also improve security posture. Detecting significant shifts in the traffic and then being able to drill down and understand the cause, such as what specific user, endpoint, or API might be compromised. BOLA. So BOLA is a well-known API threat that I'm sure you're all familiar with. But to recap, a threat actor exploits broken object level authorization to get unauthorized access to data or privileges. And I think it's really important to keep BOLA top of mind, since an attacker can escalate their privileges and impact systems using it. In this example, our VSOC team saw a threat actor manipulated IDs to access unauthorized data. We saw multiple requests sent from an uncorrelated user to a vehicle, meaning this is a user ID that's not connected to a specific VIN vehicle, and that there were multiple requests to multiple vehicles. The attacker used a valid token alongside with modified URLs to bypass the security checks. They studied the systems and fuzzed around a little bit with the URL, which we saw in the investigation. Once a session was authenticated, the system failed to verify user-specific permissions. This could have potentially allowed the attacker to access files without restriction. Had threat actors accessed the data, personal identifiable information, PII, or other sensitive information may have been exposed. And we've seen attempts to leverage the link between a user and a VIN in all sorts of ways, really, since connected vehicle services use this pairing to authorize the access information and even command. Depending on the API, which was not the case here, an attacker could have also been able to invoke commands on vehicles and access various vehicle services, all without proper authorization. Now, first, access control management must be strengthened. This ensures that only authorized users can access specific data and functionalities, significantly reducing the risk of unauthorized access. Adopting the principle of least privilege is also very important. This means granting users the minimum level of access necessary to perform their tasks, limiting the potential damage in case of a breach. Next, input validation and sanitization are crucial. By thoroughly checking and cleaning all input data, we can prevent attackers from manipulating IDs and URLs to exploit vulnerabilities. And lastly, secure development practices should be followed consistently. And this includes regular code reviews, security testing, and staying up to date with the latest security protocol to build robust and secure systems from the ground up. Next up, we have an incident involving an enumeration attack, a type of cyber attack where the threat actor systematically queries a system to discover valid identifiers like user IDs. In the automotive industry, we have VINs, vehicle identification number, which follows a Syrian pattern. This means that attackers can use generative AI tools to generate potential VINs for their attacks. And this means there is no need to mine for the data or access a database. With a single VIN, you can start to build a set for the enumeration attack. In this incident, the threat actor exploited an API in an attempt to uncover valid user identifiers, which could have led to the exposure of sensitive user information. They sent multiple requests with similar information that differed by just a single digit until they were able to identify a valid VIN. For context, in a spike like that in traffic, highly unusual behavior that goes far above and the thresholds which are normally in place for the API. Had this continued, more IDs could have been discovered. And the best way here to safeguard against enumeration attacks is to have strong security and authentication in place. And this means all authentication should be strong, using MFA where possible, tokens, and requiring strong passwords. It's also a good practice to audit your authentication to ensure that your safeguards are indeed working. API traffic monitoring that can detect the spike in traffic that an enumeration attack generates and robust detection capabilities can identify low and slow attempts. Now let's talk about the blind spot. The IT approach has a blind spot, which is why we need to expand the coverage to include the vehicle's unique context. To secure the automotive and smart mobility industry, API security must extend beyond the transaction level. Ensuring coverage of the OWASP API top 10 is an essential first step, of course, in the API security. But for automotive, the true security challenge lies in understanding and managing the intricate interactions between the API traffic and the connected vehicle state. This is why the three critical layers of automotive cybersecurity, which are API security, automotive cloud security, and vehicle security, are needed for a comprehensive view. By correlating data across these layers, we're able to detect and mitigate threats effectively, ensuring robust protection for the entire mobility ecosystem. So to wrap it all up, let's talk about the big changes happening in the automotive industry. Automakers and their partners are changing from traditional car companies into technology companies. They no longer just sell physical products, they now deliver software features alongside their hardware. Today, modern vehicles run more lines of code than an F-15 fighter jet, showing that the industry moved towards software-defined vehicles. This change involves a new approach. The industry still focuses on long product design cycles to ensure safety and quality, but now there's also a move towards agile development. And this means faster delivery of new features using software and APIs. At Upstream, when we look at connected vehicles, fleet, mobility services, and EV charging, and how APIs impact these assets, we see that they all have real-world physical effects. Vehicles driving on the road are run by computers, and understanding their interactions with applications allows us to detect anomalies in the data. And for this, context is everything. We understand this context by creating digital twin of API endpoints, API consumers, and vehicles. A digital twin is a snapshot of the state of an asset at a given point in time, built on the data we have. By creating a digital representation of the state of an asset, be it a vehicle, an API endpoint, or an API consumer, we gain insight into the context of the event. This allows us to accurately detect anomalies, comparing digital twins to get a full view of activity across a fleet of vehicles or multiple APIs. This enables near real-time detection, threats and attacks. It allows us efficient mitigation and response in our VSOC or by the company's security team. To secure the ever-evolving world of connected vehicles, A multi-layered cybersecurity stack is essential. As the automotive industry expands into the smart mobility ecosystem, vehicles are no longer the only mobility asset that challenges the cyber teams. Applying a SOC approach to the VSOC creates a more secure layering between OEMs, tier ones, telematics services providers, and other stakeholders, minimizing threats and preventing attacks. In addition to IT network security, which protects OEM servers and IT backend infrastructure from cyber attacks, the VSOC adds a new layer of protection focused on vehicle detection and response, VXDR. And there are 3 layers of automotive cybersecurity. First, API security. This is the new addition to the VSOC, and it's a joint effort between the VSOC and the IT SOC, focusing on protecting API-based applications, services, and features. Second is the automotive cloud security, using the automotive clouds to expand detection to a wide range of mobility assets and cyber threats, including vehicle telematics, OTA updates, remote commands, and diagnostics. It identifies multi-vehicle attacks with a fleet-wide view of security across vehicles, applications, and other connected services. And lastly, vehicle security, monitoring and protecting internal vehicle components, including ECUs, diagnostics, DTC data streams, OS logs, and CAN events. Each layer in the automotive infrastructure presents unique cybersecurity challenges. And these challenges can be addressed with a multi-layered approach, which includes VXDR and a purpose-built VSOC. This comprehensive strategy ensures a strong defense against ever-changing landscape of cyber threats, keeping vehicles and their systems secured.